Good morning and welcome to Race Industry Now, the weekly webinar series from ePowerTrade, presented to you by ARP, Performance Plus Global Logistics, Feria, Peak, Quire, and Fifth Third Bank Motorsports. I am Francisque Savignan, the founder and CEO of ePowerTrade, the racing industry, every minute, every day. This is episode 468, and we're going to be talking clutches with Advanced Clutch Technology, ACT. With me this morning are Judy Kin, the co-founder of ePowerTrade, and a wonderful and superstar host, Mr. Jeff Hammond. Judy?
Thank you, Francisque, and thank you everyone for joining us today. I am delighted to finally have the face of ATC join us today, Rich. Everybody knows Rich, he is everywhere. But this is the perfect scenario. He has on Matt Phil, who's a pro drifter, and then he has a race shop for drifting. Ideal partnership. Now Rich could actually, or Matt could actually go and visit end of year trade shows a few days out of the year, but now he's got a destination here to visit weekly, seeing new products, services for the racing industry. So this is the perfect combination I can't wait to hear about today. Jeff?
Well, thank you both. Good morning to both of you. Francois, are you getting a little bit early jump on the winter?
Yeah, I am.
The beard looks good. Beard looking good right there. Yeah, really excited about today. This is an area that I think a lot of us understand the principle, but know very little about the detail. And I think today is going to be very educational. And I believe Matt is with us. Matt Field. Good morning, Matt. How are you doing?
I'm doing pretty good, guys. How are you?
We're doing well. Waiting on Rich to join us, but
Awesome.
I see you getting your cap adjusted like it needs to be. You're ready to lock and load. It looks like.
Well, being a race car driver, it's all about the logo placements and the brand. So, if you haven't noticed, a race car driver checks their hat and makes sure it's square and the logo's facing the right way about 100 times a day. So I think it's just nature at this point.
Yeah, styling and profiling, and I think Rich is now tuned in and ready to go. Good morning, Rich. How are you?
Good morning, Jeff. Doing great.
Good. Well, gentlemen, it's real simple. Like I said in kind of my opening comment, a lot of people understand the word clutch, but they don't really understand the details. And I'm going to excuse myself. I can get by with saying less and you guys to talk more today. I'd appreciate it. I've been fighting hiccups all night long. Had to run down to the drugstore right quick to try to get something to kind of calm it down. But I'm really interested in learning about, your company. I'm interested in seeing about how the product works as far as the race car driver in the house. So, Rich, how about leading out and giving us a little insight and the background on advanced clutch technology, which we know has been around a long time.
Absolutely, Jeff. So ACT is a family-owned business. Dirk Starkson, the founder and president, has 45 years experience in clutch and diaphragms. And basically, ACT started 30 years ago in 1994. So we've been around a long time, and just to let you know, we're gonna do an overview of the clutch components, how each component affects engagement, holding capacity, and durability. And with that, I think we're gonna start with the flywheel. I'm gonna show you that here. I'm gonna have to stand up, y'all, so I apologize. Get out of camera here. But is there the Pro Light flywheel here too? You get that? So this is a cutaway of our Mod Twin clutch. And basically, the flywheel is right here, and I've got another one coming in, but it basically mounts directly to the engine, and it's going to add inertia to the rotating assembly. And it also has the ring gear for starting. And so that's primary the function is to add inertia and kind of give a heat sink to absorb the heat and to mount the pressure plate onto it. And the pressure plate's function, which bolts directly to the flywheel and spins with the motor at all times. So whenever the pressure plate, the clutch disc, and flywheel are spinning together as one, the pressure plate clamps onto the the pressure plate here clamps onto the disc, and that clamping force is generated by a spring, typically a diaphragm spring, which we're seeing right here. And in most modern vehicles, the force from the diaphragm spring is what you're feeling at the pedal, okay? And then through the geometry of the pressure plate, that spring force translates into clamping force that holds torque from the engine. And basically on the face, and I'm going to show you one here. There's a face right here. It would be right here where you see the blue, if you will. So basically on the face, there's a ratio there that you can change the fulcrums right here. I don't know if you could see that better. The fulcrums of the pivot on the pressure plate, like the cover assembly, and that ratio amplifies the force of that spring. But there's drawbacks to that as well. You can't do a whole lot. You could change it a little bit if you're using a stock assembly and all you're doing is changing the geometry. You're going to get an increase in that clamp load, but you're going to be sacrificing working range. And it also requires more travel to do the same amount of work. The really cool thing is when we can't get that geometry exactly how we want it, this is a raw casting, we actually make our own because we want to give you the most clamp load increase over stock that we can give you without too much travel. And basically, you will be sacrificing working range. And it also requires more travel to do the same amount of work. And the cool thing about this new Mod Twin is all the parts are modular, Jeff. And basically, we're going to talk more about twins in a little bit, but this new cover is a forged aluminum cover. And what that does is these springs want to move up, and Matt can attest to that.
I'll tell you, Rich, too, it's crazy. The difference in going from the traditional steel pressure plate that we've had for years, because my first twin plate clutch, my first clutch has always been an ACT, and it's always had the really traditional, heavier steel pressure plate face. And then when we finally kind of decided to make the turn and give me, I think I was one of the first ones to get the aluminum pressure plate for an LS specific engine. As soon as I drove it for the first time, I was like, I can tell the difference. The amount of deflection that it has, it was just so much more precise. And like you were saying, it all comes back to the actual travel and working range. I was able to shorten up the clutch stop, which enabled me to shift much quicker. And in a drift car, when the tires are spinning the entire time, if you can get that shift done just a little bit easier, a little bit faster, that means you're accelerating down the track, your foot's able to get back on the throttle a lot sooner. And I've just noticed the amount of misshifts and mishaps and quickness of shifts has improved greatly with an aluminum pressure plate. Much better.
Man, thank you, Matt. That is a true testimonial. And I tell you, the forged aluminum cover and the diaphragm spring, what's really unique about that, Matt, is, and you know this, but for everybody out there looking in, so when you look at this forged aluminum cover, this thing is so stout and strong. What it's doing is it's keeping that diaphragm spring from coming up. And let's say, show me one with the fingers, the ribs. So here's a diaphragm spring with ribs. So when we do something like that, it's going to really want to move. And this keeps it steady, it keeps it down, and it does its job, which is really cool. So I'm going to move this real quick for y'all. That didn't hurt. Okay. Show me the flat diaphragm spring. So one of the things that sets us apart, I think I can sit back down now, is we make our own diaphragm springs and engineer them from scratch. So we start with a flat piece of steel and we cut them. Okay, so you get something like that. You start with that, and then we form them, and you begin to get something like this. And it really just depends on the application and what clamp load increase we want over stock. And what happens is you can even get stuff like I was just showing you with the ribs, which makes it even stouter. So with that, It's really the factors that make up the torque capacity, and one of them being the clamp load of the pressure plate. That's probably, I would say, the most important. That's like the basics. You take an old Honda D Series Civic, right? And it's got 212 millimeter clutch. It's like maybe 900 pounds of clamp load stock. Not much. It doesn't need much. But then you compare that to an S2000. That car has way more power, and it's sporty and all that. And it's a 212 millimeter clutch.
Okay.
And the clutch just almost looks the same, but the pressure plate has way more clamp load. That's because it takes a lot more power. It makes a lot more power. And they didn't change the friction. They didn't change the size of anything. All they did is increase the clamp load. So that usually, from an OE standpoint, is kind of what you're going to find. You know, you might go a little bigger for heat capacity. In the case of an S2000, it's not a heavy car, so they didn't need to. But that's just kind of an example for you. The clamp load I mentioned before, it's a combination of the geometry of the pressure plate and the diaphragm spring. Now, what we've done that's unique is really been able to perfect the diaphragm spring designs. And what we typically see from other manufacturers is they don't mess with the diaphragm spring because it takes a lot of work. It takes a lot of understanding of the engineering behind the process, the heat treating material, the selection, and everything else, basically. We were able to expand on that. You know, with Dirk's 45 years of knowledge, we've been able to expand on it. But if you're doing the diaphragm spring, you're just, I mean, if you're not doing the diaphragm spring, you're really just limiting on what you can do with the pressure plate. And all you can do is change the geometry and apply it. And then you have the trade-offs that go with that. If you're able to manufacture a diaphragm spring, you can not only make the spring stronger, but you can also make it more rigid if you design it right, and where you get some of the flex out of the fingers of the diaphragm. And if you get that kind of efficiency out of the diaphragm spring, you're able to generate a tremendous amount of clamp load without having the penalty at the foot where it has a super, super stiff pedal, because it's about efficiency. And a lot of people don't understand is it's just how much goes on in a very short distance. We have an application with an 11-inch clutch that we increase the clamp load increase by 20 to 30%. That's not a huge increase, but it's a decent increase. But we were able to get the clutch to release in less than 200 thousandths of an inch. And that's not much for a big 11-inch clutch like that. So
no, it's not.
Oh, go ahead.
Real quick, to both of you, the same question, because we're talking about speed and efficiency. More than likely, all the people that are listening here are not maybe familiar with anything but hydraulic pedals, which engage the clutch, correct? Slave cylinder type scenario, right?
Yes.
So are there applications as far as if you don't have that luxury? Let's just say you still got the old deal where you push the pedal, the rod moves this, on the arm and all this other kind of stuff, or moves the cylinder. As far as being able to maximize what your clutches are capable of doing, is it almost absolutely necessary to have a good hydraulic clutch assembly with the right, piston throw, the whole 9 yards, if you want to maximize out what, Matt is capable of doing while he's driving?
Well, all of our stuff is meant to be used with OE. And what you just described is like a Z-bar setup.
Z-bar, good old Z-bar.
Exactly. Old
Yep.
school.
Yeah.
I'm old school right here. And wondering, about, will this stuff still work with an old system like that? Because it's still out there. I mean, I see hot rods from time to time. They still got them on there. Some race cars from the early days, vintage stuff, I still see it. It's like, why do you want to do that? I don't know. But in my mind, when I see a clutch like that, it just brings back the good old days in my mind. And it's a great way to look at it. But the practical application of it is, do you recommend if I called you and said, I'm building this engine for this kind of race car, can you hand me a blueprint and make it happen?
Absolutely. And what you're talking about is basically, we do custom discs. We have a complete way to do that online.
Mhm.
And we get a print and all that kind of stuff. But, with that Z-bar, that constantly needs adjusting so that you basically have a good air gap for the release bearing.
Yeah, don't be laughing at me, Matt, because I know I'm older than you are, but I mean that's where I got my start. I'm so that was one of the things that we used to always get in an argument about when we were putting the engine in, is trying to make sure we get that Z bar straight across and everything in line, because yeah, otherwise you are really making life miserable, and you're also running the risk of not having it. So we'll move away from that. I know you're laughing at me about bringing something like that.
No, you know why I'm
This is a
laughing?
walk down through Smithsonian.
It's the reason why I'm laughing is because other than one instance in my life have I been able to actually even look at a Z-bar and understand a Z-bar. And it was my buddy's old Chevelle, and it did have an ACT in it. It was a small block. It had a Z-bar, and when he finally pulled it out and built a 383, it was going back together. And I'm just like, what is this thing? Like, why do you still have this? Somebody definitely makes a hydraulic kit for this, right? And sure enough,
Yeah.
Willwood makes a pedal, ACT will make a clutch setup for it. Somebody obviously makes a release bearing that'll slide on the front of the input shaft. So it was still cool to see how much that car retained like a factory old school style stuff. And then through the way, because this was like his high school car, he built it with his dad, and then watching the car evolve as he learned newer things too, because that's all he knew. But being one of my best friends and seeing all the race cars and the racing components and talking about release bearings, I have the real super trick release bearings that we use in all of our race cars, to show him these pieces and be like, no, man, this is what we're using now. No one uses that stuff anymore. But to see him transition over, I was actually able to inform him on how the hydraulic release bearings works, and he showed me how the Z-bar works. So it's cool to see that stuff, but you don't hear it very often.
Yeah, I'm sure of that. And again, when he brought that display and the cutaway, it's like, I love that, because a lot of people do it with, computer generated, 3D stuff, but to see the hard, I mean, that's the real deal. That's the complete package, step by step, layer by layer. I'm more on a hands-on kind of guy, so I appreciate it. I'm not making fun of it. I'm just
no. Well, if you like that, you should see their displays at all the trade shows. It's very impressive. They got a sea of cutaways and gearboxes and a sequential gearbox on a rotator, watching the clutch release. It's quite the display that these guys have.
Oh, thanks.
And it's all about speed. It's all about speed and efficiency. You can't do what you do, man, without that kind of help. I mean, being able to pop the clutch and get it to work in sync with everything inside that bell housing is huge.
Throughout my years of racing and drifting, I've said this before, but I have learned way more about drivetrains and clutches than I probably would have wanted to. But that's all because every single clutch has their type of application. I started off my life having one drift car. That was the car that I drove to high school, that I drove to college, that I beat the crap out of on the racetrack. And it was just the one size fits all. And now we're at the point where each one of my 4 to 5 drift cars will have a different clutch, a different type of material, a different type of clamp load. They all run different release bearings, and they all have these things set up for their own reason. So I've become more seasoned than maybe I would have wanted to, but it's for good reason, I think.
Hey, you sound like you may be the marketing guy instead of maybe Rich. Rich, is he
No,
doing
I'm
a good job? Because
I'm the
he's
marketing
definitely
tool.
piquing my interest as far as how many different applications do you guys have? I mean, tell me more.
Yeah,
Oh,
Rich.
yeah, it's well over 1,200.
Crazy.
It's an amazing amount of applications when you get down to it, and really kind of dovetailing on what Matt's saying. Let's talk clutch discs for a minute, because everybody wants to know, well, what should I be using? So this here is a sprung hub disc. It's an organic full face, okay. And what these springs do, a lot of people don't realize, is they're basically gonna damper and absorb some of the torsional vibration of the motor. And that's primarily to keep the transmission quiet so the gears don't rattle. But it also prolongs the life of the splines on the hub. Because that torsional vibration is so violent on some vehicles, it can strip out these hubs. And we actually broach our own hubs in-house here at ACT. And that's what gives us the ability to make, custom stuff and be able to get the right count splines. Because sometimes you get somebody, oh, I got a 26 spline or I've got a 32 spline, and they'll ask us for certain things that they can mix and match with. So the other thing is that these discs also have like this wavy segments in between the clutch linings, and that's called a marcel. And basically what the function of a marcel does is when you're clamping onto it, you're able to progressively clamp the clutch disc. So as you're letting up the pedal, it starts to grab a little harder, and then finally get fully engaged. And that's when it's clamping down on the clutch disc and squeezing that marcel. Now, if you have no marcel at all, then the engagement is more abrupt. Now, I'm not saying it's going to chatter. It's not necessarily going to shudder, but it's going to be harder to modulate the clutch. And of course, you have the friction material on the outside, and you'll have the clutch discs. They come in different sizes, different splines. The bigger you go, really, the more torque it will hold. If everything else is the same, but then you have more inertia, it's going to be even heavier, and the inertia is going to be a little bit harder on synchros and stuff like that. Matt knows all about that.
Oh man. So with Dirk and Rich and Eric over at ACT, we had, I don't know, I want to say 3 to 5 meetings about the inertia, the size of the clutch disc, balancing out the actual torque capacity that it's going to hold, but also minimizing weight. And for a V8 engine, because all of my cars are LS, they're pretty much all supercharged. There's a couple naturally aspirated. The rotating assemblies of a V8 engine are naturally pretty heavy. So as much weight as you can get off the clutch, in my opinion, the better. Obviously, we're talking race cars here, not your daily driver. But there's also a balance, because these race cars, this thing makes 1,100 foot-pounds of torque to the tire. So we're approaching 1,200 foot-pounds of torque at the actual crank, which is where we're talking and measuring. So trying to have this balancing act of, I want the clutch smaller, I want it lighter. But then what do? Well, you end up doing stuff like this, where you have to run a triple disc. And this was something that was actually a custom-made disc for a V8. This is traditionally their Toyota 2JZ clutch, but what we were able to do is actually create a LS flywheel. And this is all after meetings and sending the flywheels back and forth, and a custom flywheel to bolt to this crank and that. But what we were able to do is eliminate all of the misshifts and all of these things with a sequential gearbox where clutch weights are very important. I would be pulling the clutch, putting in the clutch and pulling the shifter, and kind of noticing that there was this delay. But I think that the delay, when we came down to it, was all just due to clutch weight. We were kind of caught in this. We need as much clamping capacity. We want as much torque capacity as possible, because, for example, this clutch, which is basically the first big high power clutch that I've had, and that's a twin disc, that thing would last an entire season without question. I almost wouldn't even bother looking at it unless we had a gearbox problem. So I kind of figured we could take a little bit of clamp capacity out of that. We could take a little bit of life away from that and make something a little bit lighter that's going to cause these shifts to be quicker. But with that, it also comes more maintenance, right? So this little guy is super quick, super light, but you got to kind of watch out for the maintenance. And this is the happy medium. And this was the billet aluminum pressure plate that Rich was talking about earlier, which kind of gets us right in the middle of life and clamping capacity, but also less deflection and able to shift a little bit quicker.
Yeah. And Matt, with that, you've got to play this balancing act between the size of the clutch and the heat capacity of the clutch, and what amount of torque that you want to hold. And basically you were teeing me up perfectly here, because at ACC, we don't rate our clutches in stages, okay? Because what might be stage 1 to you might be stage 2 to another racer. We rate our clutches by the torque you make at the engine and not the wheels, And the other functions of the disc are going to be heat capacity. You know, the more surface area, then you have more material that's going to absorb the heat. The only time it generates heat is when you're slipping. That's it. So as you're slowly grabbing that next gear or whatever, if you're taking off from a launch for racers, if they're launching a car and they slip it out of the hole, you're basically under full power and you're
Right.
slipping it for half a second or however long that is. That time is a lot of energy that has to be absorbed in the way of heat. And once it's hooked up, you're not generating heat anymore. Everything's just spinning. Then you have the release bearing that operates the pressure plate. And it could be a hydraulic bearing. Typically, it's a hydraulic system, you know, whether it's an annular bearing or a hydraulic bearing, where the release bearing is part of a hydraulic cylinder. More often, it's an arm, and the slave cylinder is external to the bell housing. And then the bearing is operated by the arm. Did you want to show the release bearing, Matt?
Yeah, absolutely. So this is the style of release bearing that we use in a racing application. Let me get this all squared up here. And with this is a tilt and release bearing. This is like the traditional type of bearing that you would see in most motorsports applications, especially in drifting. It's incredibly reliable. The type of seals that Tilton use in this are ones like you don't have to think about it. There's a couple of important things here. An air gap is extremely important because if you don't have your air gap right, this is what's actually touching the face of the pressure plate, right? The release bearing here. And if you don't have your air gap right, you're going to push your foot on the clutch. Your master cylinder is going to put fluid into the actual cylinder. It's going to move the piston and it's going to shoot it out. So what's really important here is your air gap, the type of bearing that you have, because you see this is a radius based bearing, that you would want to make sure that the type of bearing face goes with the correct pressure plate face, right? Radius bearing, especially for these motorsports, very flat face pressure plate fingers. We have flat bearings for the billet aluminum and the steel pressure plate. And what I always knock home with all my guys at the shop and anybody that I ask and like try to educate is measuring the air gap. And every clutch company is going to have their own tolerable distance of how much gap they want, because as the clutch wears, the fingers of the pressure plate of the diaphragm will actually get closer to the bearing. So if you think about it, if your clutch discs start wearing, right, which is this thickness of your clutch disc right here, if it actually starts wearing and gets past the tolerable amount, the fingers of the diaphragm are going to come up and get pushed on by the bearing. If that happens, the clutch starts slipping and it wears out even quicker. And it's just this spiraling effect that all of a sudden your shifts aren't working. You're starting to smell clutch. You're building way too much heat. It's a lot of bad things. So you want to make sure that when you have your bearing fully installed on your app, like however it is, if it's on the front of the transmission, if it's mounted to the bell housing, you basically have a measurement from the back of the bell housing to the face of your actual release bearing. We use a straight edge to get that distance when it's all bolted together. And it would basically be from the bearing face to the bell housing. And then the same thing, you would go up to your engine, you measure to the back of the bell housing to the actual clutch face, or to the pressure plate finger face. And those distances need to be subtracted from each other. You always want to make sure that the distance between the release bearing and the fingers are shorter, right? So that you actually have an air gap here. Like in our applications, I always shoot from 0.15 to 0.20. So if you can find yourself 0.17 right in there, like you're generally pretty happy. But like I said, you always want to check with your clutch manufacturer to make sure that their air gap is desirable for what you have going on. And there's obviously a ton of different ways to adjust these, but in my application, you can see it's just a threaded sleeve that this bearing goes onto with a post that holds it. So you would just remove this bolt, unthread or thread in this bearing, and then it'll actually adjust your throw. Some release bearings have shims. Some release bearings have, if they're external, they're all built into the actual slave or on the outside of the transmission. But the key here is understanding your air gap. And if you don't know, call them up and ask them, because somebody's going to know. And that's real quick how you get a bad taste in your mouth and you don't understand what happened, but it's very, very important.
Yeah, and very, very common too. Hey, let's talk to the racers out there about the different kind of materials we have. So basically, I was showing you earlier, the organic material. And you typically find these on street cars and what comes from the factory. It's slow wearing, it's smooth engaging, it absorbs a fair amount of heat. And once it's broken in, it wears very well. And it wears very slow and it lasts a long time. And one of the drawbacks to an organic, though, is it can only take a certain amount of heat before it's overheated. And the organic material right here, when it gets overheated, it becomes more slippery because the binder that holds the material together, it's a phenolic resin. And that resin will start to melt. And when it melts, that's where you get that nice clutch smell. When clutch stinks like that, you've just taken that nice smooth surface and you just melt it off. And now the resin becomes more like a lubricant. And basically at the point until it recovers and is able to harden again, it's going to slip and it's going to keep slipping and keep wearing. So for a racer, that's not what you typically want, right? Because that means you're off in the pits having to watch the other racers compete.
And everyone knows that terrible smell. So if you come in and your car smells like that, everyone thinks the same thing. Oh, dude, that guy's day's over.
Yeah. So organic discs are light. You typically want a full surface. You want more surface area. The more, the better, because it doesn't absorb as much heat and because it will break down. So some of our clutches that we manufacture, we go bigger. You know, like we'll go from a standard, say 225 millimeter. We'll take it up to 240 millimeter. And there's a different pressure plate. And so we'll adapt something else just to be able to get more heat capacity. And that's something that, you know, is a big question with people is how you deal with the heat, right? Don't slip the clutch, but sometimes you can't avoid that. But primarily for street use, that's really what, you know, people use. But not only are they used in street clutches, but they're also used in racing too, because it's easier on the transmission. You know, typically because it doesn't have the torque capacity of the ceramic, a cerametallic, or a sintered iron would. So the coefficient of friction that we would calculate, say for the organic there, is 0.25. And you determine the torque capacity by the clamp load of the pressure plate and the coefficient of friction for the clutch disc. The number of surfaces, the typical clutch, you know, single disc, going to be, you know, 2, 1 on each side, and the radius of gyration, in other words, the size. So you have the clamp load, the friction, number of surfaces, and the size of the clutch, and that's what determines torque capacity. So now we said it's 0.25, and actually the organic materials we're using these days, it's probably considerably higher. But we've always used that number, and that's what we're going to stick with. So it's conservative, but it's not like a set number. Because, you know, in all of our testing, you see graphs where it's up, down, and all that. But just kind of an average, you know, because it's not going to be a fixed number. It depends on what parameters you put. And you got to settle with something in order to do the math. So that's why we found our numbers are pretty conservative. But, you know, that's true. Hey, now stepping into cerametallic. This is the cerametallic clutch. And some call it formic. How do you say it? Formic, I think, because it's got a lot, ceramic, because it's got a lot of iron in it. And, you know, some say copper if it has a lot of copper. But really, you know, they're all kind of, you know, I'll just put them in the same category, basically. The cerametallic button clutch type you have, buttons or pucks. We'll just call them pucks. You know, or pads. And the reason you would do pads, let's say a 6-pad instead of a full surface like we just saw, right, is because the weight. It's made of metal and ceramic, and it's a heavy material. So if you have a full surface, that puts a lot of inertia on a clutch disc. You get a lot of inertia from the clutch disc, and that's hard on synchros. And it causes the transmission to shift quiet. It makes I can't talk today, the transmission to shift a bit slower. So we'll basically use our 6 pads, or let me see, a 4-pad.
And you know, it's funny, Rich, what we do at my shop, just like what you were talking about with the organic material, sometimes we will choose an organic material clutch, even though it's going in a drift car, if we know for instance, the gearbox is made of glass, right? This car has gearbox problems. They always break the gearbox in a drifting application. Even though the customer says, I want a 6-puck, I want this, we will definitely steer them in the direction of an organic full face material, strictly because we don't want them to break differentials. We don't want them to break axles. And more often than not, the amount of power that they have is substantially under the clamping load and the torque capacity that's rated by your guys' company. So people kind of tend to overjump and overreach, and really they want the cool race clutches, but sometimes you just don't need it. I think that we need to remember here that people need to choose a clutch based off of reality and not based off of numbers on a spreadsheet, because yeah, these clutches behind me, they hold 1,100 foot-pounds of torque and up, but you don't need that if you have a more stock basic drift car that only makes 200 foot-pounds of torque. So I think we need to remember that there are all these different materials and these different sizes and faces and all these different applications and configurations for a reason.
Yeah, and honestly, I didn't realize I was holding that 4-puck up. I was like so concentrating on what I was trying to tell you. But you know, the other thing is that on these 6-pucks, for example, you do have unsprung here or sprung. You have either option, and that sprung, as we talked about earlier, is going to damp that torsional vibration that comes from the motor. So it's going to give a little more life to this and be a little bit quieter. But this is an unsprung one. The sprung one will look more like that.
Right.
Exactly like that.
But it's always a trade-off, right? You have some positive things, like it's easier on the transmission. You hear a little bit less gear noise, but it's a little bit more weight at the same time, right? It's really hard to beat one of those lightweight 4-puck solid discs at the same time. So it's a trade-off there.
It is a trade-off, and honestly, the 6-puck will hold a lot more heat than a 4-puck, obviously. But these are like an on and off switch, right? It's like bam. And so to what Matt's saying, we get people sometimes that they'll be like, oh man, my buddy's got a race car, and I'm going to put one on my street car because the clutch will last forever if it's good enough for a race. Yeah, try feathering that in a mall sometime, bro. That's not good for you, you know.
Yeah. Hey, real quick, as we get a little deeper in our presentation here, I want to remind everybody that's watching, you can ask questions, so don't let that opportunity slip by and pick these guys' brain. We've also got a comment from Tim Hilliard. Rich, we had a great time at Harry and Izzy's during the PRI 23. I'm liking the aluminum pressure plates, but have you done any for the Coyotes like what Matt runs with the LS?
Absolutely, we do. And we actually just released them a little earlier this year. So they're out there in the world, in the ether, and you can get them. And I should say this too. One of the cool things we do, because I don't know how much we're going to get to cover, but me and Matt could go all day on this thing. But on our website, we do this really cool thing called Help Me Choose. So if you're a racer, our engineers have spent a lot of time developing sort of a virtual counterman, if you will. And so you can go in there and it'll ask you, so what's your first type of, what are you going to do with this clutch, right? And what kind of torque are you going to make at the crank? Because really, at the end of the day, that's all the clutch cares about. That's all it wants to hold. And it'll walk you through some great options. And so, Tim, for that, it was a great time at PRI for sure. And it's good to hear from you, and definitely check out our Coyote stuff.
Hey, real quick, when we're talking about the torque, you talked about, the stuff like what Matt drives, which is, I'd call it lightweight, but high RPM type scenario. But what about for people who, I mean, there are a lot of guys migrating to doing stuff with diesel engines. To me, that's a lot of torque. And, what kind of challenges do you run into with that type of application, maybe that, we don't normally see?
So unfortunately, we don't do diesel truck clutches. Those kind of went away as we were getting into them, and so we sort of we backed out of that deal. So I really can't speak to that. But yeah,
probably a smart move.
And I think too, one thing you have to remember that I really want to stress to the racer out there is you have to know your driving style. you know, and your driving style is going to dictate what you need. So kind of like what Matt said, don't just go with numbers and what things say. You got to know, because there's going to be those people that just keep burning through clutches because that's how they're doing it. And there's going to be other people that, you know, they're not going to modulate the clutch so much, and they're going to drive it, you know, very keenly, and they're going to know, you know, not to do certain things. But it really comes to your confidence. And the thing that we want to do is provide a product that gives that driver that confidence. You shouldn't have to be thinking about the clutch, because then you're going to miss what's coming up on the next turn or the next person that's coming next to you, you know. And I know Matt can speak to that.
I have found that, yes, there are two types of drivers, especially in the professional drifting world. And I would say that ACT, how much of the field do you guys end up covering? I feel like it's at least half of the entire field at minimum. And me and another guy that run the same exact engine package, the same exact clutch, will send each other pictures during maintenance, and I'll be like, wow, that either looks way worse or way better than mine. But it kind of also goes to show, depending on how late you get into the competition, the driver gets a little bit more excited, they use a little bit more throttle, they dump the clutch a little bit harder. So at the end of the day, yes, everybody is going to be different. But what we all have in common is the want to not have to worry about the clutch. We know that if we start the race weekend with a fresh clutch, we're going to get 4 or 5 weekends out of it without having to open it up, without having to measure the thickness of it, without having to worry about how much wear. So it was funny when Rich and I were talking about this. We were kind of discussing some things and some topics, and we were talking about the clutch wear and measuring it. And we always do our due diligence and write the thickness of the pad material before we get it, so that if we do need to get in a situation where we're at the track, you throw some calipers on it and you go. But these clutches they don't have that problem. You change them out because you're like, they probably should be. It's been 4 races that I've been beating the crap out of this thing. We should probably put a fresh clutch in it. And I feel like that's pretty standard across the board in whatever applications. The 2JZ Toyota stuff, turbocharged engines, 4-cylinder stuff, all the way up to our supercharged V8 that we have. So I think it's more about, you know, inspiring confidence behind the driver and letting them not worry about it. And I tell Rich too, all right, I'll talk to you in, you know, the next 4 races. Or I always message Eric all the time, like, all right, like, I hate to just say thanks and I'll talk to you when I need something, but realistically, I'm not bugging these guys all the time, especially when we're not in engineering meetings trying to do something different. It's put it in the car and go run the car.
Yeah, engineering really is the majority of this company. There's so much put into the resources of engineering so that we can talk to drivers like Matt, and we get that feedback, and that feedback helps us make an even better product than we even anticipated. So that really helps us. And so thanks to Matt and what he does and the feedback that we get from different drivers, you know, we could talk about that, Matt, you know, a little bit about like clutch maintenance and what you should be looking for when we're talking about the mating surfaces. You know, there are other things you can look within the pressure plate if it wears on the surfaces. So you want to look at the friction surfaces, and then you want to look at the color of the parts, right? Did the thing turn blue? Because blue, if it turned blue, it's got a lot of heat into it. You know what I'm talking about. Like the flywheel.
You know, he must have hit a nerve.
I've been known to turn a clutch blue in my day, that's for sure. But the what I always see, it's like we write the thicknesses on them, right? And there'll be a 20 thou allowable of wear that's on this disc. And at that point, if it's worn 20 thou, chances are things like your floater and your flywheel surface and your pressure plate surface have seen some serious heat. And what we look for in these is the warpage, right? Because as you put heat in these things, they start turning blue. You see the heat spots all around them, and then they can actually start deforming. That's when you got to start worrying. I have seen floaters and pressure plate surfaces and flywheel surfaces come out completely discolored, grooved. And I'm like, how is this clutch still doing its job? It makes no sense to me that this is still doing its job, but it's because the material that ACT uses retains its shape and retains its rigidity. I'm like, yeah, that's look what Rich has.
Is that one of his?
It's getting hot. For you folks that know that reference, that was Buster Poindexter. But yeah, the color, it might be a straw color. you know, and it's got some pretty heavy heat spots on where you could tell it's seeing some heat. And then you put a straight edge on it and you find something, you know, a real good straight edge and see if it's flat. The chances are, if it's a twin disc, the floater is going to be flat because it's heated from both sides, right? And typically we don't see those warp a whole lot, but the flywheel and the pressure plate, we'll see those warp. And if you put a straight edge on it and it's more than, you know, say 20 thousandths, 10 thousandths, depends on the kind of clutch. But if it's starting to warp pretty bad, then that's telling you that the clutch is working real hard. And you may want to replace it or get it resurfaced. And not too many people do resurfacing anymore, but that's the scenario. You know, something we've said is like 20 thousandths. We've seen them where they've had 80. I mean, just they're totally concave. It depends on the clutch. Some clutches can have more mass there. They can take a lot of abuse and really, you know, get hot and not warp. You know, and then there are other ones where they're built with less mass and there's not a whole lot of material to work with. Where's that? Yeah. Let me show you this.
You know what's awesome though is even though a clutch does wear out and you do put a lot of heat into it and it gets grooved, these things are rebuildable. And that's the beautiful thing about it. Like they are built to be able to put a pair of fresh discs in there, change the diaphragm fingers, surface a flywheel, and go back together and go back out. These are no longer just a one shot and throw it in the trash. You're spending good money on a clutch. You should be able to get some life out of it. And if anything goes wrong, these guys have your back. I can't tell you, between all my race cars, I probably have 8 or 9 clutches that are in circulation at any given time. So much so that I'll just get a shipment and be like, oh, yeah, I was waiting for that clutch for the demo car. Yeah, it just came back from being freshened up and it can go back in the car, you know, whenever we have time. So that's the beauty of a quality product.
Hey guys, real quick, Mary Fields wanted to comment and ask Rich, you know, we love putting ACT twins in our Subarus down here in Texas, but any plans for a BRZ twin disc?
Absolutely. It is coming. And we're excited for it. We're just in the last stages, Mary, of testing that. The engineers wanted to see a couple other things from it, and I believe that it tested pretty healthy this last time. So they're constantly tweaking here. When we say advanced clutch, we really are advanced. I mean, these guys will tell me, hey, we made this new tweak to this flywheel. You got to go tell everybody. I go, I'm not going to tell everybody. I sold them the other stuff. And nobody I love you, but you know what? Stop that. I'm kidding. But seriously, about flywheels, our flywheels are all one-piece forged chromoly steel. That means that we don't lose any material. So these teeth can be cut right into it. And the beautiful thing about our engineers is they know that they're going to make this part. And that's what I was just talking about. This part is going to be thicker. And the reason for that is because the clutch disc is going to see this. So it's going to absorb more heat. It's going to act like a really great heat sink. And then because it's not, you know, pushed on the ring gear, you're basically, see these windows here? We can get them real close to the edge, right where they should be. So it keeps that inertia. This is a ProLite flywheel. And ProLite is basically what most people use in racing. Typically, we also have a street light. And it's pretty much the same manufacturing. It's just we'll put a little more weight in the street light. And it's one of those things where, like, we've had a twin on a Corvette that we were driving around, and Dirk didn't like the feel of it on the street. On a strip, it was great, but on the street, it was a little, you had to think about it a little too much. So he developed another flywheel that added just a little more weight, and it is perfection. It feels so smooth, and you don't even think about driving it when you're in it. So those are really key in the development of parts.
Not trying to rush this, Rich, but I just want to make you aware we're getting kind of close to the end of our time. Is there anything else that, you know, you or Matt, either one, would like to share with us, you know, before we run out of time here? Because again, we can always bring you back later on if we got more to go, but I just don't want to miss any opportunities any more than the folks out there that are listening, to make sure you guys you're available.
Yeah, no, we really appreciate the time, Jeff, Matt. Really, there's a lot to consider. We're talking about all these things, but the number one question, you know, a racer needs to ask themselves is, how much torque am I going to make at the crank? And You may be in a place where you add more power. And if you add more power and you exceed that torque limit, you need to upgrade your clutch. If you see the wear, you need to update, your clutch. But those are some of the bigs. I don't know, Matt, have you got anything else?
With me, I think just the versatility of the product and the extensive product line that you guys have. I wasn't kidding when we put an ACT in all of our customers' cars. And here at Drift Cave, it's not just my own stuff and my race cars. We have our set of customers that keep the lights on and pay the bills. And it's a constant evolution of the product itself and what the customer is going to want. And we will, from the customer side, they might think, oh, we're just putting another twin disc in another Corvette. But I'm telling you, this year alone, we put 5 different styles of twin discs in Corvettes. One is a street and track car, one is a track car, one is a straight daily driver. So really do a little bit of research. Ask people, call in, use the tool that they have on the website. I'm telling you, it works, and they make a product for everyone. And I just want to, something that stuck with me for a really long time. I was at an event, one of those rough weekends where everything that could go wrong was going wrong. Suspension failures, started to have an oil leak. One thing, broken tie rod, you get in a collision, and we're just trying to get through the day to get through qualifying, right? We need to qualify so that we can make the main show going into tomorrow. And wouldn't you know, right before qualifying, the rear main seal starts leaking. Now I know the rear main seal and all these problems arrive from having too much blow by in the engine, but what it did is it blew oil past the rear main seal and was dumping onto the clutch. And at this moment, right before qualifying, we do not have time to actually change the clutch, pull the clutch, pull the flywheel, change the rear main seal, all of that. So what we did is we made a diaper on the bottom of it. We crossed our fingers and we sent it. And the fingers were crossed to see if the clutch would actually hold with oil being dumped on it out of the rear main seal. I'll tell you, we qualified for that weekend. We had a long night that night, but we went on to do pretty well in the competition the following day. So really make sure you do your homework and you stand by the companies that stand by you, because I've been using ACT since I was a kid. I'm not kidding. 16 years old, I bought my first advanced clutch for my 4-cylinder drift car, and I've never looked back. And it's from guys like Dirk and guys like Rich and Eric and the whole crew at ACT that really make this world go round. So if you're a racer, especially somebody like me, pick up the phone, make a call. You won't be sorry.
Thank you. Hey, Jeff, one thing, we have one more question being asked, so I want to make sure.
I saw that right there. Can you comment on straps and their function, especially on driver technique?
Straps and their function?
Yeah, especially on driver technique.
What straps are we talking about? I'm confused.
That makes 2 of us.
Yeah.
Okay, well, we can get in touch with the person, and then we'll get the exact meaning of the question, and we'll forward it your way. So
I'm happy to help.
It's time to wrap up. Thank you very much for watching. It was a great session. This webinar has been recorded. It will be posted later on the ePortrait platform, distributed through our newsletter, social media channels. We push ACT's product back on the homepage of ePortrait, so please visit ePortrait.com. Next webinar will be on racing engines with Keith Dorton. So once again, thank you and goodbye.
ePortrait is a digital platform that we've created basically to make life easier in the business community of auto racing.
ePortrait, there is no e-commerce. It's literally a connection just like at a trade show. So now, any time of the year, a buyer could reach out to a supplier.
When you see a product that you're interested in, all you need to do is click on request more information, and then from there it is forwarded directly to the buyer or to the supplier.
ePortrait really eliminates having to travel, closing down your shop. Now you have a place to showcase globally your racing product and technology.
Land speed record holder George Poteet's Speed Demon rocketed 481 miles per hour at the Bonneville Salt Flats. You don't go that fast without ARP fasteners.
There is no way that we could go the speed that we've gone, the number of times we've gone, with a lesser quality bolt than ARP supplies to us. And we absolutely wouldn't be where we were today if it weren't for ARP.
When failure is not an option, it's ARP-bolts.com.
We're Performance Plus Global Logistics. Our team of dedicated performance industry and logistics experts get valuable cars and components to the track on time in top condition. We provide expedited logistics solutions for the performance industry using direct routes instead of deferred options, and communicate all necessary information to the appropriate resources to meet regulations and ensure a smooth transit and secure delivery, both domestically and internationally. And we exceed customer expectations by providing best-in-class service with an efficient and cost-effective system in place. Contact us today to book your next shipment.
You work as hard as your truck, and you have no time for downtime. That's why more truck owners trust Blue Def, America's #1 diesel exhaust fluid brand. Each batch is guaranteed pure, so you can avoid costly repairs caused by inferior DEF. Demand America's best for your truck. Blue Def and Blue Def Platinum. Put trust in your truck.
Roots in the Midwest that date back well before the Model T, Fifth Third Bank has a long history of serving the needs of automotive companies. While much has changed over the years, our passion for helping businesses put cars on the road and on the track has not. Today, we are more committed than ever as a member of SEMA, a founding member of PRI, and a sponsor of multiple race teams across several racing series.
For over a decade, Fifth Third Bank has been a staunch supporter of our industry and a great partner for many companies in the motorsports field.
Our business has been growing extremely fast, and really we could not be where we are today without Fifth Third. They provided amazing strategic advice, the capital we need to support our phase as a group.
They are true partners for me now, and what they do with their involvement in motorsports is untouched in this community.
Where can we take your business? Fifth Third Bank.
Where will you find Farea racing components, circle track, drag racing, and any top race shop? In every form of motorsports competition, our valves and valve train components deliver race-proven design and technology. And we've brought that same performance to our street applications as well. We're backed by 5 decades of experience, an extensive range of off-the-shelf components, and our custom valve department has the fastest turnaround times in the industry. Farea Racing Components. Stand with us or race against us.
When it comes to pushing the limits of performance, the pros know there's no room for compromise. At Crowder Cams, we don't just engineer camshafts and valve train components, we redefine what power means. Since 1955, Crowder Cams has been the name trusted by racers, engine builders, and gearheads around the globe. Whether you're building a street machine, a dragster, or a track car, Crowder Cams provides the muscle you need to dominate. And with Crowder, victory is within your reach.